Hi, I'm Rishab. I am a developer evangelist at Twilio and a Google Cloud GDE. So the title of my talk today is Build GCP Certification Tutor with Gemini and LangChain. So who all here has tried out LangChain? I'm guessing few people. See a few hands up. Yep, it's an AI conference. So people who haven't will be going through LangChain. It's an open source framework. So I'm gonna try to make this exciting. I was thinking of doing a live demo, so like having live coding aspect to it. But I gave this talk, similar talk to this, 3 weeks ago at Developer Week, and I ran out of time. So I have the code snippets. We'll go over it within LangChain. But you can take this tutor example and you can implement this with your own business use case. Most common one that I see is building like internal chatbot for your internal teams because the LLMs are not trained on non-public. They're not trained on the non-public information. So let's get started with the talk. As you can see, a lot of words. Again, this is generated by AI. AI has overrun the world, and so did the amount of information that is available for us builders. I know it can be overwhelming. It is, at least for me, but we'll be covering a few of the words that you see here in this word cloud today in my talk. And as I already told you, that was AI generated through Gemini. So what will be the content of the talks today? Limitations of LLMs. I'm going to be talking about why we need some things like RAG, and then we'll talk about what RAG is, how you can implement it, and of course, the open source framework called LangChain. And then I also have a demo to show you all. So think about GCP certifications tutor for today's example. If I just ask a certification question to any of the large language models, it can be open source ones like Gemma or Phi from Microsoft, or Llama from Meta, or it could be OpenAI's ChatGPT, or even Gemini. I'm going to take a guess that the answer will not be up to date because there are a few limitations. First of them being the cutoff. So for Gemini 1.5 Pro, the knowledge cutoff is May 2024. That's till when the model is trained on. Similarly, other models have their own cutoffs. So if there were certification updates that were made to any of the GCP certifications, as you can already tell, I love cloud certifications. That's how I have upskilled in my career. If the certifications were updated, which in most cases they are, it is not going to have the up-to-date information. The second is no knowledge about the certification at all. This is very less likely to happen now because how big the large language models have gotten and the vast amount of data that these companies are training it on. But this is a good example when you are bringing something that is your internal knowledge base, right? So Google and OpenAI, they don't have access to your company's data, at least that's the case. So no knowledge is another limitation. The third one is LLMs can hallucinate. So if they don't have relevant information, there are some guardrails around it with like Google AI Studio. OpenAI has their own. It is also possible to have guardrails with open source models. But if you don't use them, LLMs will hallucinate. And the third one is working with a limited context window. So Gemini is kind of solving this problem because the 1.5 Flash, I guess, has 1 million token limit, which is a lot. But again, it's all relative. It all comes down to how much data you are bringing. Because with a certification, yes, I could copy my certification guide and just paste it in ChatGPT and ask relevant questions. But if it's your company's database or something that is more than 1 million token, or you're using a model that has less token limit, you'll run into that. Okay, now we'll expand the LLM capabilities. There are a few ways that you can do that. First one is retraining. So all these three solutions are kind of solving the challenges or limitations we saw on the last slide. Retraining is adding your own data into the training set when the model is trained. Fine-tuning, on the other hand, I take an example with baking. So I love cooking and baking. That is what I do outside of sitting on my desk. Retraining can be an example of, you started from scratch, right? Whereas fine-tuning is that you had like a pre-made base of a cake, and then you're just adding some decorations on top of it. That's what fine-tuning is. Whereas RAG combines an LLM with a retrieval system. So you provide your own knowledge sources or data, and we do a retrieval of that information when we are asking a question to the LLM, and we say, hey, this is the relevant information that I pass, or that I have, that I want to pass it to you. Generate responses according to this data that I've given. So it makes it context aware, is another term that I see floating around. But out of these three solutions, I'm going to be showing you RAG because that's the most cost effective. And honestly, I don't have the money and the resources to train my own AI model. So we'll be sticking with RAG today. There are a few steps within RAG. So the first one is chunking, which we'll go into detail on all these 4 steps. Then we generate embeddings. We store those generated embeddings, and the last process or step is to retrieve those embeddings. Okay, so chunking. Chunking is the process of breaking large data into smaller chunks. Pretty self-explanatory. But here is an example. This is a terms and condition document of a fictional car rental company that I created, again, using AI. Once we do chunking, this is what it would look like. For visualization purposes, I don't have a key thing here called overlap because I didn't know how I could present that with different colors. But typically, there's also overlap between characters or sentences, depending on what chunking strategy you use. Then we take these chunks and generate embeddings. So embeddings are a way of representing data in numerical form. That is the simplest kind of definition, because these large language models, they cannot interpret information as letters. They need it in numerical form, which is where also comes thing called vectors. So once you generate these embeddings, you'll get a vector representation of the text that we just saw, and this is what it would look like. So again, same TOC document. Once we generate embeddings, this is what it would look like. And now comes the fun part of storing these generated embeddings. So this is straightforward because we get back the arrays or vectors, and we store that. We need a database to store that. There are great examples like Pinecone that you might have used, or even Vertex AI Vector Search. But traditional databases like Postgres or SQLite can also be used here. When it comes to the GCP RAG ecosystem, these are all the vector databases that are available, or you can use them as vector databases. I know the text might be too small, but I have tried using Firestore, BigQuery, and Vertex AI Vector Search. That was the one that I was going to use today, but it took me around 40 minutes, I want to say, to spin up my Vertex AI Vector Search instance, and it is expensive. So I'll show you both examples in today's talk, but we'll be using BigQuery because it's very easy to set up and it's very cost effective. Now, the fourth step was the last step of RAG was retrieving these embeddings. So this actually means that whatever our user asks or whatever I ask my GCP certification tutor to take the query and do a similarity search on that query towards my database and get relevant information and pass that along to the LLM. this is what helps the LLM with that context-aware answers. Now comes the fun part of talking about LangChain. So LangChain is an open source framework, as I said. It allows developers working with AI to build LLM-powered application by bringing in your own data and your own compute in certain cases. The framework is currently offered in Python and JavaScript/TypeScript. I'll be using the Python version. And the three main concepts, as you can see, are the prompt or components of LangChain is prompt, model, and vector store. So prompt is basically the instructions that you want to pass along to your large language model. Model is what large language model you want to use, right? And then vector store gives us access to any of the vector databases that we might have integrated. Chain is what brings all of these main components all together. So this is what the architecture kind of will look like today. Large language model, I wanted to use Gemma, but I don't have as powerful of a laptop today with me. So it takes a while to generate responses. Gemma, as you know, is an open source model by Google. You can use a tool like Olama to run it locally, so you're not sending it something to the cloud or calling an API to generate responses. It runs local on your own hardware. So for folks who are kind of privacy focused, you can run your own models if you have a good machine. But today I'll be using Gemini, and I'll show you how easy it is to switch within LangChain to a different model or a local running model. Vertex AI is what I'll be using for my embeddings model. BigQuery, as I told you, that I'll be using it as the database or the vector store for today. And LangChain is what is going to bring all of this together. It is funny that I only have one GIF in today's slides. I usually am a GIF person or GIF person, however you pronounce it. And if you want to have a cool debate after the talk, if it's pronounced GIF or GIF, I'm up for it. But yeah, let's get into it. So let me get my Visual Studio Code up here. Let's see how much time it takes to bring it to the right screen. OK, there we go. So this is the part where I was telling that I don't want to code all of this live because I'll run out of time. And since I said that, let's check on time. Still have 15 minutes. OK, so how many of you are here Python developers or are familiar with Python? OK, good amount of hands. Awesome. The code here is not going to be complex, I promise. It is pretty easy to understand. So we'll go over it step by step. On the top, you can see a bunch of imports are happening. Again, GitHub repository will be linked at the end of the talk, so you can use this. The important ones, as I said, are the Vertex AI, because we'll be using the embeddings model. You can also see BigQuery on line 7. And also let me know at the back if the code is readable. I think this is a good time to check, see a few thumbs ups. Awesome. OK. Then I'm doing environment variable, loading the environment variables. I don't want to expose them. They're in the .env file somewhere there. I'll not show it, I promise. OK, so the first thing is the embedding models. As I said, I'm using the text embedding 005, which is from Vertex AI embeddings. You can use any of those. There are also open source ones that are available. So here, I have a list of URLs. These are basically links to the PDF of the GCP certification guide, but this could be anything. You could upload your own PDFs, or it could be links to your documentation site. You get the idea. So the first step of RAG was chunking. This is what is happening here from line 28 to 31. You can see I'm using the unstructured URL loader. Again, LangChain has a lot of helpful stuff. So this is also from LangChain. You can use this loader to extract the text from a website or a URL. That's what I'm doing. And then you can also see LangChain comes with the character text splitter. I'm using that to create chunks of size 2000 with the chunk overlap of 200. So this is where that term I was mentioning I couldn't visualize is overlap. So the last 200 kind of characters will be overlapped between documents. So it'll exist on the first chunk, but it'll also exist on the second chunk as the doc. Okay, now, since we have the chunks, we have to create vectors out of this, so generate the embeddings, but we also need BigQuery as our vector store. So that is happening from line 38, as you can see, to line 45. Pretty simple. All of this is, again, set up in the environment variables file. So you need your GCP project. You need your data set, your table name, and the region which is in it, and the embedding model. So if you don't have all of this created, the first time you pass this and run the script, it'll create it for you. Now, the only thing left is to add this to our vector store. So the generated embeddings, as you can see, we use the embedding model that we defined earlier on top to generate the embeddings and also store it into our BigQuery, which is why we use the vector store.add_documents. So I have a search.py file, if I'm not wrong. Let me see. There we go. So let's see if I can open up my terminal. Awesome. Make sure that my virtual environment is activated. I should probably mirror my screen. This is so hot. There we go. Okay. So now if I do Python 3 search, yes, search.py, let's see how fast is the internet. But I'll also show you what is in the search.py. So search.py is basically me doing a similarity search on the query, as you can see, called security here. So I wanted to see if the knowledge base has been created, so like our vector store has all the relevant information or not. To test that, I'm doing a similarity search on just a word called security. What has happened in the terminal, as you can see, is it has returned all the documents that has the word security in it. So now we can use this similarity search function within our application. So this is where the fun begins. Let me close my terminal. Okay. So all of this is copy-paste of the knowledge-base.py, as you can tell. This basically is connecting to BigQuery vector store. The embedding model is the same as you saw. And this is where the main Python function comes in called AI_helper. So within LangChain, you can define your large language model. I'm using the Google Generative AI model Gemini 1.5 Pro, but you can replace this, as I said, if I wanted to run Ollama or locally running open source model, I would just replace this with Ollama and whatever the model name is. So documents is where I'm doing a similarity search on the query that is passed to the function. So this will be something that the user asks or I can ask, right? So this, as you can see, this is an argument in my main function. It is passed to the similarity search as well. And then 3 main components of LangChain. One was model, the other one was prompt, right? So this is where the prompt comes in. As you can see, I've given the model a set of instructions. So you are a helpful tutor that can answer questions and concerns about Google Cloud certifications, and you can read the next, is that the answer the users and you can see I'm using the curly brackets. So this is where input variables come in within LangChain. This is anything that can be dynamic. So this is not hard-coded, apart from the prompt itself, based on the information provided here, where I'm passing in the docs. So the docs will be the similarity search based on the query. Now, we learned in the slide that chain is what all brings together. So chain is being used here to bring in the prompt and the LLM together. And you can see that we are invoking the chain and returning it as a response for our function. I do have a print statement to try it out, on how I can pass the Associate Cloud Engineer exam. This is one of the certifications. So let's try running it. Since I am not great at creating front-end applications or UI, I do have something in my streamlit.py. So Streamlit makes it very easy to create, good-looking interfaces using Python. And this is exactly my interface built with Streamlit. So instead of doing it in the terminal, we can use this. So I'm going to bring this down so that I don't hurt my neck more. OK, this is better. So I'm going to open my terminal, do Streamlit run, streamlit.py, and we can go into our browser here. Where is my mouse? There we go. OK. To localhost 8501, which is the default kind of port. Let's see how long it takes to run it. And there you go. So we have our Google Cloud Certifications chatbot. It gives a brief information of what I can ask. So let's try something a bit more complex. Hey, give me a cool project idea for GCP Associate Cloud Engineer, because I truly believe to learn something, you need to get your hands dirty and be hands-on. So how I learn is usually by building projects that are focused towards the skills that are covered within the certification. Let's see. And while I do that, let's also check on the time. We have still 5 minutes. OK, so I typed it out. Yes? Sorry. So you're saying that the prompt is more about the instructions on what to answer rather than to train? Sorry, I'm having a hard time hearing you. No. So this is not the prompt. This is just a brief information about my chatbot. The prompt that I showed you is still in that file. Yeah. So these two are not the same thing. I mean, this text you're referring to. This. Yeah, so that is my question. Yes. Yes. Yeah, that is the query that is being passed to the function. Oh, you mean like a zero-shot approach? Kind of, yes, but I have been very explicit in my prompt template. This is one example, but I can later show you another example where my prompt template is like a huge doc. because I want it to be very specific of what it tells. I know it is not same as guardrails because, you can do prompt injection and get things out of the large language model. But yeah, good question though. Yes?
How did you determine the chunk size and the overlap values?
For those one, do you want the honest answer? I just copied it from the LangChain docs for this demo. There is another GitHub repo that I have where I went really into strategizing the chunk size and overlap specific for the model that I was asking. Yeah, for Gemini, I honestly feel you can have bigger context. So like you can have chunks bigger than 2000 to have more context. But there's also an argument within your similarity search on the number of docs that needs to be returned. So you can set that to 5, you can set that to 10. So like when you do a similarity search, instead of 3 docs by default, you can get 10 docs if your model has bigger context. Great questions. Okay. As I said, my UI skills. I could clean this up, but you can see it generated a multi-tier web application project that is geared towards the Associate Cloud Engineer certification. How I know this is because I can tell from the services being used within GCP, things like Cloud SQL, Cloud Functions, Cloud Run. It is very detailed. And I'll probably have a cool demo at the end. Let's see, let's try to cover this up. Okay, next slide. So this kind of is what we built. This is the diagram, architecture diagram. But this basically allows you to build large language model applications with this kind of general pipeline. Your user comes in, they ask very specific questions about your product, about your docs, or about even some internal documents that you might have trained it on, like the example that I was showing with terms and conditions of a car rental company. We do a similarity search on our vector store as soon as the user asks it. We get relevant information. That relevant information is passed along with the question that we got from the user to the large language model, could be any of your choice, to get a really good answer, which the model might not be trained on because we are providing it the relevant context. And since I work at Twilio, I did hook this application up to a WhatsApp number. So I won't do anything with your numbers, trust me on this. You can scan this QR code and it should open up WhatsApp. The bot is, again, the GCP certification bot. Any of you who may be studying for GCP certifications, or if you want to kind of test the application we built today, go ahead, try to break it. I would love to see if you are able to, find some issues with my bot here or my application. But yeah, scan that QR code, and we're right on time. So, as promised, I do have QR code for the slides and the GitHub repository with all my socials as well. So feel free to scan that, and happy to connect with any one of you if you have any further questions about the talk. Thank you so much.